Lori DeToro, Senior Communications Manager for Turntide Technologies. Thank you for joining us today to learn more about hybrid configurations and benefits. We're thrilled to have Head of Product for Hybrid and EDU Systems, Jason Glass, presenting with us this morning. Thanks so much for being here, Jason.
Oh, you're welcome.
Before we get started, we have some housekeeping tips to share. This presentation is being recorded and will be available on demand on the Current Wave website. We will be taking questions at the end of the presentation, so please use the Q&A section to ask your questions anytime during the webinar, and we will answer as many as possible. Jason has also offered to answer some in the middle of the webinar, so as time permits, we'll get those questions asked, as many as we can. We also have the link for our May webinar in the chat. This webinar will cover axial flux motors and inverters in power generation applications. So go ahead and register for that before you log out of the session. And remember that this is a live event. So when we mess up, and we will, laugh along with us. Okay, that's it for housekeeping. We're ready to get started. Jason, take it away. And there may be some of your devices that are making some noises back there, if you can mute
That's
them.
my alert from Teams.
Okay.
Yeah. Hey, everybody. It's my name's Jason Glass. I'm the head of product for diesel hybrid and our EDU line. Super excited today to kind of walk you guys through some of the configurations and the benefits of hybrid systems. We're going to be focusing a lot on what we can bring to the market, where Turntide strengths are. We'll walk through a little bit about our product and that sort of thing, and then we'll jump in to the meat of everything. As we're going along, if you guys have questions about a slide, I like for it to be interactive. So please, just raise your hand, ask your question, and I'll try and answer those while I'm on the slide so we can have a little bit more of a conversation around the data that you see on the slide. So going forward, let me see if I can silence that. I can't. Sorry about that.
Yeah, if you put it on Do Not Disturb, we should be good.
All right, let me do that real quick, just in case. All right. Should be good to go. Sorry about that, guys. All right. So the first thing we'll kind of walk through today, again, we're talking about the axial flux motor from Turntide, and how flexible this really is within the market, and how it applies to not just automotive, but how we can introduce the axial flux motor to off highway, for construction equipment, for your marine side, and then class 8, trucking, whether it be over the road or potentially mid-mile or even last mile delivery platform. So it's an extremely versatile platform, and really what we're hoping to do and what we're planning to do is kind of bring this globally into multiple markets all at the same time. Again, trying to focus on those commercial applications, and trying to also keep in mind, as you guys are developing things and as we're developing things, one of the key parts of this is how serviceable can we make the platform as we partner with you guys. Real quick, what is axial flux? And it's kind of a term that's gaining a lot of momentum in the market. It's a product that's growing very, very rapidly in the market. And to put it as simple as possible, an axial flux motor is an electric motor that applies the magnetic forces actually along the rotation axis. So we're going to apply that force to the axis of rotation instead of along the axis or across the axis like you would in a radial flux motor. And the advantages there are that we have a very, very lightweight system, and we'll continue to talk about that. But the Turntide design is not unique, but special within the market in that we have dual stator and single rotor design. So we have a much lower rotational mass. We're able to kind of cool those stators a little bit more efficiently. And you can see the cooling jacket on the outside. This also allows us to give multiple sizes, and also because it's a hollow bore design, we're able to stack those motors. So it's a great design for you guys, and also allows you to have a very, very compact package envelope. Some of the advantages of axial flux. So again, that compact design, it's really, really small. I have one sitting on the shelf behind me. If you can see it, they range from, 4.5 to 6 inches thick, which is great for tight space constraints. Lighter, a radial motor gives you a 50% kind of power to weight ratio, or less weight when you're looking at the design of the motor, so you're not having to hang this huge massive motor off the back of your prime mover in order to generate power. So less rotational mass means our bearings last longer, giving us a longer motor life and more efficiency. So we're running about 95 to 96% efficient on the axial flux design that we currently have today. Again, we look at the axial flux motor not as a single point of entry into the market, but as a multiple point of entry. And the reason for that is we have multiple diameters and we can stack those motors. So our smallest motor being a 250 millimeter motor, all the way up to our largest motor, which is 430 millimeters. And each of those motors can be stacked to double, triple, quadruple the standard power rating in there. So that gives us a power band of 55 kilowatts all the way up to a full megawatt of power. And so, very, very nimble in the design. So we have an SAE1 to SAE5 motor flange design. So each of these motors can be fit up to multiple different motor sizes. Common shaft designs. So across our motors, we're using the same spline design, same spline size across all of them. So again, gives you as a customer a lot of options when it comes to designing a system, but also having different levels within the same package of production. So it just gives you a lot of design options. That also means that it's very easy to drop this in between your prime mover, your engine, and a transfer case, a gearbox, transmission. So it's very easy to drop in between those because our width is so small. So what are some of the advantages of the axial flux motor in a hybrid system? The biggest thing from my perspective, and I think a lot of our customers would agree, is high torque at low speeds. A lot of our diesel motors that we're working with are 3,600 RPM is kind of the peak of where they perform. It's the perfect range for us. Low speed, high torque means high power production. And with those 4 different configurations, we have a lot of different ways to reduce total cost of ownership when we look at retrofit and OEM applications for hybridization. So when we get into your total cost of ownership, the electrification of an ICE drive line here is going to give you the option to do a couple of different things. And, we're going to be able to improve vehicle range through range extender functionality. So how do we incorporate that? We can use it with a transfer case. We can put it in between the motor and the bell housing with a torsional coupler and torque converter and that sort of thing. You can use it just for traction. You can also use it for power generation. You can also use it as a power takeoff drive. So some of the larger equipment that we're working on now, we're actually doing power takeoffs for air compressors, for hydraulic pumps, for a lot of different functional systems on tractor trailers, construction equipment, and that sort of thing that are normally power thieves from our prime mover. So we're able to kind of separate those drive lines out, electrify hydraulics, electrify air generation, and also generate power just off the prime mover. So a lot of different applications that we can bring into play. Again, you're going to see an increase or decrease in total cost of ownership because now we're putting that diesel motor or that prime mover in its sweet spot. So we're able to really do some awesome things with increasing motor life, decreasing planned maintenance intervals. So instead of running on miles, now you can run on hours. We're decreasing downtime by removing transmissions, which are wearing out really, really fast in our last mile and mid mile platforms. Reduced oil changes and other planned maintenance, because again, we're keeping that diesel or that ICE motor in its sweet spot. Excuse me. And we're completely agnostic. So it could be a diesel. It could be, we're looking at diesel platforms from 1.5 liters all the way up to 15 liters. We're looking at radial diesels. We're looking at all kinds of really awesome prime movers that are coming into the market, adapting these axial flux motors to match those new ideas around power generation and hybrid drives. So we look at scalability. One of the things that we want to do is give you guys the option to say, okay, we're going to start out today. We want to generate 50 kilowatts of power, or maybe it's 100 kilowatts of power. But we know in the future, we're going to want to produce 150 or 200 kilowatts of power or more, right? So we can start out with one size and then help you guys scale by either double stacking motors or going from, say, a 300 millimeter motor to a 400 millimeter motor, or 400 to 430. So you have a lot of options there to help you scale as you build out your platforms. The other thing that's really awesome about the design is we're working with you as customers to create drop-in designs that allow you to not have to redesign an entire chassis. And here on this picture down here, you'll kind of see a truck chassis with the original motor design with an axial flux motor on the back. And you'll see there's no transmission. Behind that is an axial flux motor with a drop box that drops in where the carrier bearing would normally be, where your axle splits to make that angle. We're going to put a gearbox there and say, hey, you're dropping in, so nothing from that carrier bearing back has to change in your platform. So if you're trying to go to a series hybrid or just power generation or a full BEV even, you can drop this system into your current existing chassis and electrify that chassis, either BEV through series hybrid or parallel hybrid even, through the road, so that you have a system that doesn't require you to redesign your entire platform. For retrofitters, this is a huge advantage, whether it's a dump truck, a trash truck, a logging truck, a last mile delivery truck, but gaining a lot of traction in front end loaders that are making repetitive forward and backwards motions, highly adaptable into those type systems of electrification as well. So really exciting possibilities for you guys, and the sky's the limit on pretty much what you can decide you want to try and make and hybridize your platform. So we look at performance economics. You're looking at about 50% less weight, a 96% efficiency, which is really awesome, because one of the things that we can also do, and we'll talk about it again in another slide, is let's say you're looking at hybridizing a platform that utilizes a 6.7 liter diesel, or not just a Cummins but a Duramax, or one of the other diesels. There's a lot of them out there, and John Deere and those sort of things. But you can downsize from that 6 liter motor to, say, a 4 liter motor, generate the same amount of electrical power, and be able to create a lighter, more nimble vehicle by downsizing that diesel when we're using it as a generator instead of a traction drive. So, again, there's versatility, there's different architectures that we can utilize to help you guys really enter the market in a powerful way. As we look at some of the challenges that you guys might face with hybridization, a lot of the systems that we see now are 3-in-1, 4-in-1, 5-in-1, even some 7 and 8-in-1 systems. The axial flux motor gives you the ability to have a less complex but yet compact system that allows for increased serviceability. And this is something that I think gets missed sometimes in the market is how serviceable is your platform going to be for that end user and their maintenance folks. So a lot of what we look at when we look at hybridization is how can we create a highly serviceable system? Because some of the systems that we've seen and some of the systems that I've been looking at from a competitive standpoint are highly integrated, complex systems, some of them requiring that you remove the entire chassis, the entire powertrain to service them. And then to service them, you have to send them, globally to be worked on because they're so integrated and complex. What we're trying to help you guys do is design a highly serviceable, highly maintainable, highly durable hybrid system that will fit into your current platform. So a huge advantage there when it comes to axial flux. So with hybridization, we look at fleet vehicles, and one of the really awesome things about this is your performance gain. So you've got torque dense designs, you've got inverter controlled propulsion, which means you can limit how that vehicle is being driven. A good example of that is the young man who delivers my packages here. He drives that poor truck like it was stolen. So on the gas, off the gas, on the gas, off the gas. So really working that motor hard, working that transmission hard. We're able to actually create with you guys profiles to allow that propulsion system to be monitored, to be take a lot of the pressure off of it and really get some performance gains out of it, again affecting your total cost of ownership. We have noise reduction. So instead of the diesel being running, the diesel or your ICE motor running at full power all the time, again, it's running at that quieter, nice, optimal RPM for power generation, for turbo heat, for exhaust heat. It's running cleaner. You're doing less maintenance. Again, decreasing that total cost of ownership and, decreasing your tailpipe emissions as well. So a lot of advantages. Again, total cost of ownership there is going to be reduced, right? So, some of our customers, some of the platforms, when we go to a series hybrid, we're removing that transmission. Again, that transmission is getting worked really hard. First, second, third gear clutches, they're wearing out faster because of the way the trucks are driven. They're always at low miles, low speeds, which is working that, those first three gear clutches really, really hard. Now you don't have to do flushes as often. You're not wearing that transmission out as fast. Again, reducing that repair and that replacement cost. Improved uptime. Again, brake life is going to get better because we're using regenerative braking. Tire wear would get better. Lighter drivetrains. So a lot of advantages to that. And then we're also going to have fuel reduction, high efficiency conversions across load ranges. We can actually adapt it to vehicle weight. So one of the really cool things, if you're doing like an autonomous last mile delivery or mid-mile, distribution center to retailer, is we can design the drivetrain and the control system so that, as that load gets lighter, our performance gets better, obviously. But how do we capture that heavy load performance so that you're getting better performance out of that platform at heavy loads and then increasing it even more as that load gets lighter? And how do we balance that out for fuel consumption? So really interesting things going on there. Again, reduced maintenance, less thermal stress, fewer, moving componentry and that sort of thing. Again, we get into how do we go from a 6-liter motor down to a 4-liter motor? Again, reduction in fuel costs, still generating a lot of power, up to 100 kilowatts of power as we decrease that motor size, keeping that battery and the optimal SOC for performance, and simplifying serviceability and making it easier for you guys and your customers to maintain a platform. So what would a system like this look like? So we're going to kind of talk about the multi-flex hybrid system that we've been working on here at Turntide and some of our customers. This is an internal combustion engine designed with our axial flux motors. a transmission, and a transfer case. So multiple different functionality systems going on here. So with this multi-flex system, it's a ICE and electric motor drivetrain with variability in that drivetrain to meet your specific applications or the driving profile or the state of charge of your battery. So multiple different ways of controlling this system, and having these axial flux motors do multiple things in the same platform. So we have multiple different drivetrain options and configurations in this design. With the multi-flex hybrid, we're also, we're looking at somewhere between 159 horsepower, 410 peak out of the ICE drive, about 1,000 foot-pounds of torque, 2,300, peak foot-pounds of torque, and 120 kilowatts of power generation out of this system. So you can run it as a full BEV. So the electric only mode means maybe we're in a geofenced location where diesels have been banned, or it's best to not run the diesel. So here we go into shut the diesel down, run only on the dual axial flux motors. And again, we're running on that battery, which can be anywhere from a 40 kilowatt battery to a 200 kilowatt hour battery, equal to your current diesel platform power. So you're not losing any power, and running on just that BEV system. And that's anywhere between a 1.8 liter diesel and a 15 liter diesel, is what this system is kind of designed to function around. The ICE mode is a really cool option because that allows us to transmit that torque directly through those axial flux motors. And the axial flux motor from Turntide is designed to freewheel, so we can actually generate power or not. So let's say your battery reaches, 95% SOC. You're going to be, maybe you're in a Class 8 truck driving over the highway. That diesel is incredibly efficient. You want to turn that system down or turn it completely off. Now you're just running completely on ICE, or you could get hill climbing EV boost out of the EV system as well. So multiple different systems functioning all on the same platform inside this design. Within the system, you can use your ICE to generate just electrical power, again, incredibly efficient in that city, last mile, local mile delivery trucks, low speed applications. High frequency of stops is where we're seeing massive fuel economy increases, 20 to 30% in some of those high, frequency stops, route driving, and that sort of thing. And within this system, again, we can run 350 horsepower, 261 kilowatts, peaking out at about 745 kilowatts out of the system, or 1,000 horsepower, 2,000 foot-pounds of torque, and then peaking out somewhere around that 4,500 foot-pounds of torque, out of the entire system through the transfer case. So an incredibly power-dense design that allows you guys to have the massive, the highest amount of options when it comes to how this drivetrain can be applied in a commercial vehicle and pretty much any vehicle on the marketplace. So we look at some of the other applications where we've done, actual power generation. You'll see, the CMD 6-liter diesel there being used as just a power generation unit. This can be done for marine applications where it's hugely popular right now, from small craft to large craft to autonomous crafts, using the Turntide axial flux motor as their power generation for that autonomous drivetrain. Again, small size, it's only 110 millimeters thick. And then, we can run them all the way up to 325 Newton meters of torque. We've got up to 750 volt operation. So anywhere between 250, 280 kilowatts, volts, all the way up to 750 volts. Again, using them as propulsion or generator drives. And then, how do we continue to electrify different platforms and making it as easy as possible to integrate. Commercial vehicle electrification. So, a large diesel driven commercial vehicle, you're looking at a 12-ton vehicle, you're looking at a continuous electrical power generation of around 73 kilowatts, and then all the way up to 217 kilowatts of power generation out of a double stacked AF 400D. So, again, huge power generation, and the opportunity to downsize that diesel, again, decreasing total cost of ownership and allowing you guys to really get in there and find a system that's going to work best for you. Lower voltage inverters too. We've got the 400 volt inverters that we use now for your electric light commercial vehicles. So we do the electric motor, we do the inverters as well. So you've kind of got both of those. We also have gearbox options. We have transmission options that we're working with as well, to help you guys kind of look at this platform and say, hey, how do we create something new in the marketplace? How do we reduce that fleet total cost of ownership? And how do we create a platform that's going to be as versatile and dynamic as possible? Our new Gen 6 inverter is out now within the market as well. So we're able to pair not just the motor, but also get you the power electronics, help you guys identify battery options, whether it's a turn-tied battery or third-party battery, and the entire control system as well. So trying to be as dynamic and whole system supportive as we can possibly be as a customer, or for you as a customer. Some of the things that we need for customer success. As you guys look at hybridization, what are you going to require for your vehicle, right? So, up to this is an example of a 55-ton truck. Using the turn-tied platform, using the AF 400D, which is a double stack 400 millimeter motor. Very, very tight packaging constraint on this particular package. So we were able to kind of fit it in to where they needed it to fit and still make that 1200 Newton meters of torque. Again, pairing that with our Gen 6 size 9. After 10 months, right there at the bottom, you can really see lower thermals, better performance out of the truck, improved drivability, flexibility, and now we've got multiple configurations that we can fit into that package. And we did it in a very, very tight timeline. So huge success with this particular customer testing this product line out on their platform. So kind of quick through that. I know I kind of tried to get through it in 30 minutes. We'll open it up for questions. If you guys have any questions, you want to email me directly. You want to start a conversation, my email's up there on the screen. Feel free to reach out to me. My email is actually jason.glass@turntide.com, not jasonglass@turntide.com.
Yeah, that's my typo.
So, but yeah, we'll open it up. I can jump back to any slides that you guys would want to see. And then we can kind of have a conversation around where we're at.
Well, one question that has come through is, can you give us the basic difference between a parallel hybrid and a series hybrid system?
Sure. Yeah. So in the parallel system, your ICE motor has a continued connection all the time to your drivetrain. And that drivetrain is also generating power at the same time. Where a series hybrid drivetrain is where your power generation, prime mover are completely disconnected from that drivetrain. So the drivetrain is 100% electric, and your range extension or your power generation is completely separate from that drivetrain.
And for series hybrid, what are some specific applications or recommended applications for that kind of system?
Some of the ones that we're seeing it the most popular in is in the, your mid delivery or mid-mile delivery truck. like a lot of fleet companies are looking at where they have a large truck like this, like, you know, this box truck design that is making multiple stops throughout the day. So some of these trucks are running 15, 20, 30, 40 stops a day. Some running 100,000 miles a year. We're finding this to be the hottest place in the market where this is being applied. Also, other ones are like school buses that are running continuous routes. You know, and in inner city buses as well, where they're running constant stops, but they're on the road all the time using this system as well. So those are some of the hottest areas, and you know, one of the fastest growing applications here in the U.S. is with autonomous delivery vehicles, with autonomous DoD vehicles, where we're doing power generation and traction, but the two are disconnected for multiple theater of operation, you know, requirements and that sort of thing.
Okay, next question we have is, are you working on vocational applications for this as a replacement to hydraulic transmission driven PTOs, looking to replace inefficient hydraulic auxiliaries or hydrostatic systems for vocational trucks?
Yeah, absolutely. That's where our power takeoff comes in. We have multiple different designs of a power takeoff system where you could, you know, if you want to run an ICE motor with a transfer case, or even a multi-pad system where you want to get rid of that diesel motor and go electric, we can stretch that drivetrain, add an electric motor to that multi-pad or that transfer case, and then bolt that hydraulic system directly onto it, or use our smaller 250 millimeter motor as that pump drive, all the way down to our 48 volt motor, for a pump drive to take that load off of your ICE drivetrain and move it to an EPTO or to a purely electric hydraulic pneumatic system.
All right, we have a lot more questions coming in. What is the smallest diesel you've used as far as kilowatt output for one of these systems?
The smallest diesel we've used so far is a 35 horsepower um, diesel motor with our 250 millimeter axial flux motor. That's the smallest one we've done. And this one makes about 25 kilowatts of continuous power with that system. That's kind of the most compact, tiny version that we've done so far.
One person has said that slide 21 is cut off at the bottom. Is there anything major missing on that? That was a statement for slide 21.
I don't think.
No,
Oh,
I think
it looks like this
that's,
box.
yeah, that's
There we
all
go.
of it. Oh, there you go. Thanks,
Sorry
Mark.
about that. Proof
Okay,
of concept vehicle.
gonna go back to questions. So there's a lot in this one. I know I will tell you, Eric, for battery partnerships, that's and battery companies we work with, that's something we'll take offline because I think there are multiple options there, and that probably is a better offline question. But the other part of your question, what voltage do they output? And can you talk about your conversion options?
So the output from our motor can be anywhere between, I might get this wrong, but I'm gonna hedge my bet a little bit here. Anywhere, so we can output anywhere between 260 volts to 750 volts, and we can output anywhere from 25 kilowatts all the way up to 480 kilowatts of power. I might be a little bit off on that range, but those are the kind of the ranges for power production for us when we're in power generation mode. For conversion options, if we're talking about platform conversion options, it's anything from Class 8 tractor trailers, over the road logging trucks. We've worked with trash trucks or garbage trucks. We're doing platforms that are skid steers. we're doing front end loaders, we're doing telehandlers, airport baggage handling companies. So the conversion option there is, can we go from an ICE, if you want to keep that power generation, to your current transmission? Yes, we can. If you want to separate the drive line out, maintain that transmission, we can also help you develop the adapter between electrification and that transmission. If you want to go directly into the transfer case, we can go directly into that transfer case, use it as an all-wheel drive transfer case, use that transfer case as a single output, single input drop box to align with a drivetrain. So kind of my role at Turntide is looking at every single conversion option on the market and really going into, how do we prototype these things? How do we do test beds with our customers? How do we develop new and innovative ways to do conversions? Even to, looking at transfer case inputs that would hybridize a drivetrain and not really have to mess with anything transfer case forward. So there's a lot of different options that we can kind of pursue with you guys as customers.
And that leads right into this next question. We were actually, before the webinar started, talking about some connectors that we've created or had built for this. Does Turntide have any products that ease the connection between the ICE and the axial flux motor?
Yeah, so we have well-developed products, and I mean, you can kind of see a little bit in some of the pictures the idea. If you give me a second, we have adapter rings that look like this that we manufacture, or we have manufactured for us, that allow you to bolt right onto an SAE 3 through 5 flange at the moment. We're working on an SAE 1 and 2 flange. So we'll either design it for you or we'll help you design an adapter between our axial flux and whether it be your transfer case, a gearbox, the bell housing adapter that you happen to be using, because all of those things require a torsional coupler to mitigate the torque ripple that comes from a lot of diesels. When that cylinder fires, we've got to take up that momentary torque application. So we use torsional couplers. So it kind of depends on what your design looks like. Do we want to adapt to the flywheel, torsional coupler, electric motor, torque converter, electric motor, electric motor, torque converter, transmission? So there's a lot of different configurations that go into that. But we've been working on different platforms. Currently for the SAE3, we have almost a complete package where it is motor adapter, it is flex plate, it is torsional coupler, shafting, and everything to make a generator. And then we can help you design the input or the output side of that axial flux motor to either go into a transmission, transfer case, gearbox, whatever. So, lots of different options.
Sorry, I didn't mean to interrupt you.
You're right. I talk fast enough.
Are the transmission gearboxes designed by Turntide, or No. We're not going to talk about partners right now, but we are working with partners for those, correct?
Yeah, we have several partners that we work with for gearboxes, transmissions, and transfer cases.
And Jason can tell you more about that offline. If you email him. Is there any maintenance to be taken into account, perhaps aligned with the ICE maintenance? I know we've talked about reduced maintenance, so maybe you can talk about that, and if there's any other maintenance.
Yeah, so depending on the powertrain that you have or the system that you have, if you look at maintaining your axial flux motor, there's basically no maintenance other than making sure that the coupler is maintaining its health. So let's say you're using a torsional coupler. With our torsional coupler ring, we actually have an inspection port that's machined into it so that you can inspect that torsional coupler. The axial flux motor itself is just based on bearing life, and then maintaining the thermal side of it, making sure that your glycol is doing well, that your system is still full. That sort of thing is pretty much the only thing we have to watch and maintain, other than when you're doing a normal oil change, you may want to check your torsional couplers and that sort of thing. That's pretty much the only maintenance that you have to add to the system.
And if you're using your diesel engine less, you're probably going to stretch out your maintenance intervals on those too. Yeah.
Right.
Are you working directly with any commercial vehicle OEMs at this time? I know we can't mention that specifically. And what is your sense of commercial availability timing for OEM-backed setups?
Obviously, we're excited to work with all the different OEMs. We do have some that we're working with now. I don't know what the commercial availability is going to be for those systems. That's kind of not a timeline that we can control. I know we're working with several different customers that are trying to get to market pretty rapidly. But yeah, at this time, I don't know when it's going to be commercially available from an OEM yet. But our motors are available today, so it kind of depends on timing for them.
I'm going to ask this one. It may be something we need to take offline. How are you navigating EPA regulations on the small diesels?
So yeah, that's an offline question because that's a about 30-minute
That's a big
conversation.
calculation. Yeah.
Yeah,
Um,
yeah. There's a
but
lot that goes into that depending on the platform and how you're using it, and whether it's an industrial motor, commercial motor. There's a lot of factors that go into that EPA regulation
right.
side of it. So that's definitely an offline conversation. We can definitely set up a meeting to have that conversation.
So in these systems that we're talking about, you can use a smaller diesel than you would typically use if you were just running on diesel. So that's going to help too. I always like to throw that out there. Um, Let me see. With your compact design, does it require a water cooling or is normal airflow sufficient? So you can answer that.
Yeah, all of our systems are glycol cooled, so they do require cooling.
Um, there were some that were similar, so I'm just trying to make sure I haven't missed any. Connection. We had so many questions. Y'all are doing great out there, attendees. Um, yeah, does Turntide have test lab facilities for bench testing of prototype motor-driven ancillaries?
Yes, we do. We do have our own dyno facilities
Mhm.
located in Gateshead in the UK. So we have two different testings, locations there that we can utilize to test whether it be EPTO, drivetrain, hydraulic system, and pneumatic systems.
So what is the impact on the energy consumption when the motors are in freewheel, assuming there is energy required to offset BEMF of the motor?
So the I'll kind of answer this quick, and then we can get into a larger conversation if we want to have a meeting. So the way our motor is designed, our rotational mass is extremely low. And so when the motor goes into freewheel, basically all that rotor is doing is just spinning. We're not demanding any torque. It does make a micro amount of voltage as it spins, but that's managed by the inverter. So in freewheel, our takeaway or our scavenging or parasitic draw from the diesel is sub half a kilowatt, maybe, if not less than that. I would say sub half a kilowatt would be a huge amount based on our motor. So when it's just in freewheel, that rotational mass isn't creating drag on the system. Obviously, you have efficiency losses, bearings, drive shafts, so on and so forth, thermal, losses and that sort of thing. But it's extremely minimal when you're looking at just driving torque through the motor and not having the motor demand any torque at all. Hopefully that answers
Okay.
it very
If
high
not,
level.
you can re-ask. You said you had a converter flinch available 3 and 5, or was it 3-5 so that you do have SAE4 available or not?
Yes, so we have SA 3, 4, 5 today. Um, and then we're working on SA 1 and 2. And then if we have, if you need something that's custom, usually takes us about a week and a half to 2 weeks to design a custom, maybe depending on your application, right? You may be going direct to the back of the block because you don't want to use the bell housing adapter. There's a lot of different configurations that we're working with right now. But yeah, basically SAE 3, 4, and 5 are ready today. and then 1 and 2 are coming, and then smaller, obviously.
Awesome. Thank you.
Not too many smaller than an SAE5, but
So are they liquid cooled? Details around that, which I know you've talked a little bit, but here's the other part of the question. Is it integrated with engine coolant or a separate system? Optimal operating temperature for this?
so the system is typically separate. So just because your ICE engine is going to be able to run a lot hotter than our axial flux motor likes to run, um, the we're going to try and keep that motor as cool as we possibly can. So having a separate cooling system is the preferred and ideal way to cool that motor. And then I can, if you shoot me an email, I can get you the actual. I don't want to quote it off the top of my head what the ideal temperature, operating temperature of the motor is. I want to say it's somewhere around. I can't. I don't want to quote it because I'd just be wrong. But I can, if you shoot me an email, I can, or we can, I think we've got your email address. I'll shoot you the spec sheet and we can
Yeah, you'll have email addresses. The questions will be by it, but I am putting right now Jason's email, since I had it wrong on the slide, in the chat. So you'll be able to grab that and email Jason directly.
Yeah.
And Jason, you have so many questions. For generation, I will call it regenerative braking in marine direct drive applications. On anchor and river current, and what is the minimum RPMs for generating power? Does all that make sense?
Ooh, wow, that's a cool question. Never thought about that. From being an anchored or moored in position, allowing the prop to generate power. That's a cool question. So the minimum speed that we need to turn the motor to generate power, it pretty much will generate power from zero. I think the last question I had with Martrish Van was somewhere around 100 RPM. It would kind of be the basis to start applying a lot of torque. But that's kind of a scenario we haven't ever run through. But man, that's an awesome question. Wow, that's a really cool question. Sorry, I got a little caught up in the
You got distracted by the coolness of that.
kind of set my brain on fire there. Of all right, how do we do that, and how would it look, and what would the system look like? That's a great question. If we could set up a meeting around that, that would be an awesome question to explore. But I think the minimum rotation would be somewhere between 50 and 100 RPM to start demanding, torque. We'd have to look at how much torque, prop size, and that sort of thing, and current speed in order to know how much torque that could generate, because the amount of power we can generate is directly related to how much torque we can apply to the motor. So if it's turning really, really slow, the cool thing about axial flux is slow speed, we can actually generate massive amounts of torque. So that's a great question. I will definitely email you and follow up on that, because I'd love to continue that conversation.
Awesome. Another question. We've got a little more time. Do you recommend a chiller then if you are on a separate system?
So
for the cooling,
we can do liquid to air cooling is most of the time going to be fine. Depends on how hard we're working the motor. The bigger concern there is going to be keeping the inverter cool. So we always focus primarily on making sure our inverter is running as cool as possible. Motor, obviously secondary to the inverter, keeping that motor cool, and then focusing again on the thermal limitations of the battery. So it's whole system thermal design. If you're doing heavy regenerative braking or heavy, a lot of stops, we may look at thermal limitations. Obviously, cooler the motor is, the better that motor wants to generate power, which is kind of a hard thing to manage with batteries. So batteries don't like to get too cold, too hot. So the cooler we can keep that motor and inverter, the better our system efficiency is. But we could just have to look at the platform design to make sure that we're staying within those limits and then keeping that motor as cool as possible.
Okay, so we have a few more minutes for questions. So if you go ahead and get those asked, I'll be able to answer them. I did want to say one other thing in addition to what we've talked about. Jason will be at ACT Expo. So if you're going to be at ACT Expo, email Jason, set up a time to chat while you're there, meet in person. And you can ask as many questions of Jason as you'd like. So just want to let you know that he will be at that show. And Jason, I'm not seeing any other questions come in, so I'm ready to close it out if you are.
Yeah.
Thanks, everyone, for taking the time today. Jason, thank you for a very informative. Hold on, one question came in.
Awesome.
What are the coldest temperature? Can you operate in Arctic cold temperatures? That's the last question. Then I'll start my thank you over
Yeah.
again.
So we do cold weather testing. You get into Arctic temperatures, it becomes more about bearing rating than it becomes about our system because, again, that system being cold, we may actually have to warm up the glycol and that sort of thing. But they do run very, very well at extreme cold temperatures. Extreme cold is going to be more about bearing design and bearing selection because we would want to change that bearing selection for extreme cold operation. But our motors perform extremely well at extremely cold temperatures. Obviously, computers love being cold, so that inverter is going to love being cold. But it really is about bearing selection at that point. That's an excellent question, and we do have partners for extreme cold weather bearings. So.
All right, so that was officially our last questions. Thanks again, everyone, for joining us. Jason, thank you again. This was a very great presentation, but even better conversation with the attendees. So thank you guys for chiming in with your questions. This webinar will be available recorded on demand in about 48 hours. We hope you'll click the link for the May webinar in the chat and join us then. And we hope y'all have a great week. Thank you guys so much.
Thank you, guys.